Okay, good. We're recording now. All right, so we're going over section 4.2 today. Section 4.2 today. Example 1. We've already gone over a lot of this information yesterday when we went over 4.1. So 4.2, we're finding reference angles right now for negative 135 degrees and 17 pi over 6 radians. Now, there's some formulas in the book that you can use to find the reference angles. But know this, reference angles, wherever they are drawn or measured off the x-axis, no matter which quadrant that you find them in, quadrant 1, 2, 3, or 4. The important thing to do is this. With the negative 135 degrees, you know you're going to be moving in the clockwise direction. The x-axis here is your initial side of the angle. The terminal side is going to be in which quadrant? Where's the negative 135 degrees going to be? If I start here at 0 degrees, run the negative direction here. It's not going to be quadrant 2. Quadrant 2 would be where a positive 135 would stop. We have 180 degrees over here negative for the negative direction. Okay? So a negative 135 degrees is going to be just short of that. This is a negative 90 degrees right here. So between a negative 90 and a negative 180 is going to be this negative 135. So we're in quadrant 3. So just looking at this, how far off the x-axis is a negative 135 degrees? I mean, how far am I to be being at a negative 180 degrees? What is the difference between 180 and 135? 45. So my angle rho, I'm going to call this angle rho, so I'm going to use that. Okay? My angle rho is going to be 45 degrees. So what I'm going to do is I'm going to find, that's all this is doing is you're just trying to find the reference angle for a negative 135 degrees, and this is it right here, 45 degrees. That's your reference angle. So in other words, you would refer, if you wanted to find the trigonometric functions, the values at a negative 135, you would refer to the 45 degree angle to get those numbers. Then since you're over here in quadrant 3, you would attach the negative sign in front of sine, cosine, secant, cosecant, and keep tangent and cotangent positive, because in quadrant 3, that's the rule for your sines, for those 6 functions. Now, radian measure, 17 pi over 6. Where is 17 pi over 6 going to be? Well, first of all, let's think 0 radians. We're going in the positive direction. Yes, we need to find where the angle is. All right, so we're trying to find the reference angle for 17 pi over 6. All right, again, let's try this. Hopefully I won't get interrupted again. All right, now when I'm going around the circle here, 0 radians, we're talking about radian measure now. 90 degrees is the same thing in radian measure as pi over 2. Let's first get that down. Halfway around is pi radians. 3/4 of the way around, 3 pi over 2, good. Right? That's analogous to 270 degrees. And then all the way around, we decided it's 2 pi, right? 1 revolution in radian measure, we're talking 2 pi, all right? So we've got 17 pi over 6. Where is that on the circle here? If I work my way around the origin, how many is there? 17 pi over 6. I know that if I think of that as 12 pi over 6 plus 5 pi over 6, right? Hold on. If I think of this as 12 pi over 6 and 5 pi over 6, this is my 17 pi over 6. And now the reason I want to do this is because there is 1 full revolution contained in 17 pi over 6. In other words, you know, if I break this up, 12 pi over 6 is 2 pi, isn't it? So what I've done here for 17 pi over 6, the first 12 pi over 6 parts takes me all the way around. Now, I've got another 5 pi over 6 units to go. 5 pi over 6 is going to take me around through quadrant 1, And I'm going to end up over here in quadrant 2. How do I know? Well, 6 pi over 6 would be another pi, further pi units around, halfway around. So I'm just short of that. So I am over here, my terminal side of my angle is here. This is where 17 pi over 6, the terminal side where it stops. All right. Now, at 17 pi over 6, I had to go a further 5 pi over 6 units past 2 pi. So how many radian units am I off of the x-axis? If it would take 6 pi over 6 units to equal to pi, I want you to think about it just like this. 6 pi over 6 would equal to pi, wouldn't it? So I'm 1 pi over 6 in terms of 6. I am pi over 6 radians off of the negative x-axis. So what I'm doing here is I'm basically saying, therefore, my reference angle is pi over 6 radians. I don't really need to put the superscript r on there. You see the Greek letter pi, it is in radian measured, but anyway. So that's what we're talking about here. So you have to find the reference angles for angles in degrees and in radian measured. You can rest assured, by the way, 17 pi over 6, the reference angle is probably going to be pi over 6 because my denominator is in terms of 6. Yes? Can I do pi over 6 in degrees? 17 pi over 6 is given in radians. If I do this in degrees, I've got to translate it into degree measure from radian measure. I can do that. If I want to translate 17 pi over 6 to degrees, okay, what I've got to multiply by is 180 over pi. That's how I convert into degrees. The pi's cancel. 6 goes into 180 30 times. So I'm talking 17 times 30. Okay, so that's going to equal to 510 degrees. So if you think about it in terms of degrees, what we've done, remember 360 degrees is one full revolution in degrees. So again, I would start here, work my way all the way around. That's the first 360. And to get to 510, I need to go another, 150 degrees around? So I'll stop at the same place, which is 30 degrees off the negative x-axis, isn't it? And 30 degrees is equal to pi over 6 radians in radian measure. So if I gave this to you in degrees, if you did it in degrees, your reference angle would be 30 degrees. But it's given to you in radian measure, so it's pi over 6 radians. Okay, example 2. Find the value of the sine of 150 degrees and cosine 150 degrees. Well, the first thing we want to do is establish the reference angle. What is the reference angle? If I sketch where 150 degrees is in the Cartesian coordinate plane, starting over here, initial side on the x-axis, I come over here to, this is theta is 150 degrees. Well, 180 degrees is all the way over here on the other side of the origin. So my reference angle, rho, is going to be 30 degrees. So I'm going to refer to the value of sine and cosine at 30 degrees to figure out what the value is going to be at 150. Now, the sine at 150 degrees. Now, is the value of sine in quadrant 2 going to be positive or negative? So that means the value of the sine of it 150 is going to be the same as the sine at 30 degrees. Which is going to be, it will be. But what is sine at 30 degrees? Do you remember that? Sine at 30.
Pi over 6.
Well, that would be the radian measure. What is the value of the sine? 1/2. That would be the radian measure of 30 degrees. Now, what about the cosine? Cosine at 150, I'm also going to refer to the 30 degree reference angle. But cosine is negative over here in quadrant 2. So that means what I'm going to do is I'm going to attach a negative, and whatever cosine is at 30 degrees, the negative of it is going to be what the value of cosine is going to be at 150. So what is the cosine of 30 degrees? A negative the square root of 3 over 2. Well, cosine of 30 is square root of 3 over 2, but you have to attach a negative in front of it because you're not in quadrant 1 now. You're in quadrant 2. So we're talking negative square root of 3 over 2. Okay? So the sine is 1/2, but the cosine of 150 is a negative square root of 3 over 2. But in both cases, I had to refer to the 30-degree angle to get these numbers. Then understanding what quadrant that I was in, I then attach negatives or positives to the numbers. And it's going to change depending on what quadrant that you find yourself in. But you use your reference angle to get the actual number part of the answer. But then you have to understand what quadrant you're in to attach the sign to the proper sign to those numbers.
Okay, everybody, turn your books to page 58. Go to page 58. At the top of the page, there is a trigonometric function value and reference angle value table. You don't have to, but I do want you to be familiar with it. Basically, what it's telling you in the first quadrant, okay, in the first quadrant, the sine of the given angle, say theta, let's say it's 30 degrees. Well, in the first quadrant, the angle is your reference angle, isn't it? In the first quadrant, your angle is your reference angle, so that the sine of the angle, we would say, is equal to the sine of the reference angle. Okay, the value, the numeric value, and the positive or negative sign that would be attached to it. And the same thing with cosine theta is going to be, it's going to be equal to the cosine of rho, the reference angle, all the way down through all 6 trigonometric functions. Everything's the same. When you get over here into quadrant 2, in the second quadrant, which is quadrant 2, okay? The sine of the angle theta, like the sine of 150 degrees, is going to be equal to the sine of the reference angle, like the sine of 30 degrees. They carry the same numeric value and the same sign. But the cosine of theta, when you're in the second quadrant, is going to be the negative of the cosine of the reference angle. All right, similar analogies can be made in the third quadrant. You know, when you're talking about the third quadrant, okay, the third quadrant, you're going to have the sine of the angle. Since you're in quadrant 3, you're going to refer to the reference angle, angle rho, but you're going to put a negative in front of the sine, okay? So that if I were over here, let's say 210 degrees, I'm in quadrant 3, but my reference angle is 30 degrees. But since the sine is negative in quadrant 3, I take the value of sine, which occurs in quadrant 1 at 30 degrees, put a negative in front. That's the value of sine in quadrant 3. Cosine, the same way. Cosine theta is going to be equal to the negative cosine of the reference angle in that quadrant. And you can look on page 58 for a more exhaustive list of all 6 trigonometric functions, the sines of the angles, and their reference angles, being determined by what quadrant that you find yourself in. Okay? Okay, now watch this. We're going to rewrite, I'm on example 3 now, page 58. We're going to rewrite each function as the same function of a positive acute angle. All right, let me continue on here, okay? Rewrite each function as the same function of a positive acute angle. If I want to find the secant, 305 degrees, that's the first one here. We're going to rewrite secant 305 degrees. I'm not going to actually try to find the value, but I want to rewrite this as a function of a positive acute angle. So 305 degrees, which quadrant am I in? Which quadrant?
4.
4. How far off the x-axis am I? At 305 degrees, how far off the x-axis am I? 55 degrees. 55. So I'm going to reach my reference angle, rho, is equal to 55 degrees. Now, secant, do I associate this with sine or cosine?
Sine.
No. Secant, sine or cosine? Cosine, yeah.
That's what I said.
You said sine or cosine. Associated with cosine, you said that, I apologize. The deal is this though, you're in quadrant 4 now, so is cosine positive or negative?
It is positive.
So that means secant at 305 is going to be equal to a positive value of secant at 55 degrees, okay? This is how you rewrite these functions here in terms of a positive acute angle here, all right? So this is what I would do. This is how I would answer that. Now, at 11 pi over 6, sine 11 pi over 6. An acute angle is going to be between 0 radians and pi over 2 radians. Which quadrant are we in at 11 pi over 6?
4.
Okay, we're in quadrant 4, yeah, okay? So in quadrant 4 is sine positive or negative?
Negative.
Okay, so I'm going to say a negative sine, because we're in quadrant 4. What is the reference angle?
30.
Give me it in radians. Because it's given in radians. Problem's in radians. Yeah, because on pi over 6 units are radians off the.
You take on my bracelet.
Okay, your homework's going to be on page 60, 1 through 26. Get that done. We didn't get through all the example problems. See what you can do with it. We'll probably have to do some more review and talking about this tomorrow. But that's going to be the homework assignment, okay?